This is the Unit 4.1 Writing and Graphing Linear Inequalities video lesson. Your TEKS are A2H, Write Linear Inequalities, and A2D, Graph the solution sets of linear inequalities. So your learning goals for today is that you can write a linear inequality and you can graph the solution sets. A linear inequality is a linear relationship that involves an inequality. For example, y is less than or equal to 3x plus 1. You'll notice this is different than what we have worked with so far when we were graphing equations. This has an inequality symbol. We'll talk more about those symbols in a few minutes. A solution to a linear inequality is a point that falls on an included line, or a solid line, we'll learn, or it's in a shaded area. If I was to graph this inequality, then it would look like this. And so we have a solid line. We'll learn that the reason why is because it's equal to, and because this is less than, it's shaded below. So we're going to see three different points in the areas that they could be in. And so this point is not in the shaded area and not on a solid line, so it's not a solution. This point is in the shaded area, so it is a solution. This point falls less than the line. And this point is on the line. That means it's equal to this line, so it is a solution. So once again, if a point is in a shaded area or on a solid line, it's a solution. If it's in a non-shaded area or a dotted line, it is not a solution. So when the inequality is evaluated, it makes the statement true. And we'll see that also. We're going to plug in. Remember, evaluate means to plug in. So we're going to look at this inequality. It says, given the example in the point 7, 3, in the inequality y is less than x minus 1, it wants us to test that point to tell if it is a solution or not. Remember, points are made up of x's and y's. So my x is 7 and my y is 3, and we're going to plug those in. And so 3 is my y, 7 is my x. 7 minus 1 is 6. Is this statement true or false? Is 3 less than 6? That is a true statement. Since it's true, we would say that the point 7, 3 is a solution to that inequality. Let's try another one. We have y is greater than 3x plus 2. The point 1, 5, the x is 1, the y is 5. If I plug that in, you're going to see that the y is 5 and the x is 1. 3 times 1 is 3. 3 plus 2 is 5. Is this a true or false statement? Is 5 greater than 5? And that would be a false statement. 5 is equal to, but not greater to. And so since that is false, it would not be a solution to that equation. One more. If we take this inequality and we take the point 2, 1, I'm going to plug in the 1 and the 2. 12 times 2 is 24. 24 minus 7 is 17. Is this a true or false statement? Is 1 greater than or equal to 17? And that is false. Since it's false, then that point would not be a solution. So one way to check for solutions is to evaluate. Plug in the x and y and check to see if the result is true or false. Now, we can also test points on graphs. We're going to look at the same three we just worked. And this is already graphed for you. We have y is less than x minus 1. And I'm just going to test the point 7, 3. The point 7, 3 falls here. We go to the right, 7 and up 3. And it is in the shaded area. Therefore, it is a solution. The second example is y is greater than 3x plus 2. When I graph this, you see that I have a dotted line. When I plot the point 1, 5, it falls on a dotted line or a broken line. In this case, that would not be a solution. And we saw that also when we were evaluating. The third example is y is greater than or equal to 12x minus 7. When I plot the point 2, 1, you see that it is not in a shaded area. And since it's not in a shaded area, just like when we evaluated, it is a false statement, so it's not a solution. Now, it's very important you write these in your notes and memorize them. This is one of those tables that you're going to have memorized to make your work more efficient. So in order to graph inequalities, there's a few things you've got to remember. First thing, always have the y by itself. In other words, you want it to be in slope-intercept form. Remember, we always do that no matter what. If the y is not by itself, you need to make that happen. The second thing you need to remember is if you multiply or divide by a negative, you must flip the sign. Okay, flip the sign. Graph the line as you normally would. and then look at the symbol to tell what type of line to draw and where to shade. So let's look at these types of symbols. The first symbol we have here is less than. Now, if you don't know the difference between less than and greater than, the easiest way to remember is which one looks like an L. Does this look more like an L, or does this look more like an L? This is less than. It looks like an L if you were to turn it just a little bit. Another way to do it is put both of your hands up in front of you and look at your fingers on the left side, and that it looks like an L. Left is L, it's pointing to the left. Right does not look like that. So this is less than. It's going to be a dotted line or a broken line. Greater than is a dotted or broken line. This symbol is less than or equal to, so it's a solid line. Greater than or equal to is also a solid line. Now for the shading. Less than, if you think about the y-axis, where is all the numbers that are less than a number? That would be down below, so we would shade below. Greater than will be higher, be numbers that are bigger than some number on the y-axis, so we would shade above. Less than or equal to, shade below. Greater than or equal to, we would shade above. So now I'm going to give you an example of what each one looks like. So less than is a dotted line that is shaded below the line. Greater than is a dotted line that is shaded above the line. Less than or equal to is a solid line that is shaded below. Greater than or equal to is a solid line that is shaded above. Make sure you have written these tables down and spend a little bit of time committing these to memory because they will save you a lot of time. Now let's practice graphing some inequalities. So this is in slope-intercept form. We have y by itself. So we're going to begin with the b, just like when we graphed equations. So I'm going to put a point on the y-intercept at 4. And then our slope is 3 over 1. So I'm going to go up 3 and to the right 1. Now I'm going to look at my symbol. Since my symbol is less than, if you remember from the previous chart, it's going to be a dotted or broken line. Also, less than means that we're going to shade below the line. So I shade everything below the line. Example number 5, we're going to do the same steps. We're going to start with the y-intercept. I'm going to plot the point at 0, 3. And then my slope is negative 3 over 2. Now this can be tricky, just like when we were graphing equations. You got to make sure you're only using the negative on the top or the bottom. You cannot put it on both. A negative 3 over negative 2 would be a positive, and that would change the value of that coefficient. And so we want to make sure that we're either putting the negative on top or on bottom. It doesn't matter which one. If you put it on top, you would go down 3 and to the right 2. If you put it on bottom, you would go up 3 and to the left 2. In this case, I went down 3 and to the right 2. When I look at my symbol, I have greater than or equal to. That means it's going to be a solid line. And greater than means to shade above. Now, the way I remember the shading is I'll put my pencil on the y-intercept and say, where are all the y's that are bigger than that number? So what's bigger than 3? 4, 5, 6 or 2, 1, 0? Well, it would obviously be 4, 5, 6. So I'm going to be shading above. Example number 6, we cannot graph this yet because the y is not by itself. And so we need to get the y by itself. So I've written down the inequality, and I'm going to solve it the same way that we have all the way back since Unit 1. I'm going to subtract 4x from both sides. Then I'm going to divide all parts by negative 3. You're left with y is less than 4/3 x minus 4. I want you to notice that I had to flip the inequality symbol because I divided by a negative number. Now that we're in slope-intercept form, we can begin to graph this just like the previous 2 examples. So I'm going to start at negative 4. And then my slope is a 4/3. That tells me I'm going to rise 4 and run 3. When I look at my symbol, I know it's going to be a broken or dotted line. And since it's less than, I'm going to shade below. Now, you have to do it that way, where if they give you an inequality, you have to be able to graph it, but also you need to be able to write an inequality from a graph. So just like with equations, we're going to start by identifying what the b and the m are. And so my b is going to be the y-intercept. I have it designated as a green, and it's going to be at -1. Then we're going to pick another point on the line to help us, and then we're going to do rise over run. So in this case, I would rise 2 and run 4. So my slope is a 2/4, which would reduce to 1/2. Now looking at our shading and our line, which symbol would we use? It's a solid line, so I would use one of these symbols, and it's shaded above, so I would use the greater than symbol. So it's going to be greater than or equal to. So now my inequality is y is greater than or equal to 2/4 x minus 1. Now you would also want to reduce this 2/4 to 1/2. Okay, that's everything for this unit. Make sure that you have completed your quiz and taken your attendance. Also, you need to complete your practice assignment, the STAR checkout, and the ticket out the door for today. If you have any questions, please attend tutorials, and I'll be glad to help. Have a great day.